Today we study the Calculus 1. Our topic is continuity of functions. So now look at, do you remember some function is continuous? You don't have some idea. So now, this class will give some idea about continuous, means which function is continuous at some point C, how to give the definition. So now look at the figure. From the figure we can find it. The limit f(x) at 10 to c does not exist. Look at the second figure. fc exists, but the limit f(x) doesn't equal the value of fc. Now look at the figure 3. Limit f(x) at 10 to c, the limit exists and equals the function value f(x) at the given point c. From the figure we can find figure 1, f(x) is not continuous. This is not continuous. Why? The point here, not continuous, means discontinuous. And pick 3, yes, continuous. Pay attention to this expression. From this expression, we will give some idea about our definition. Look at the definition, continuity at a given point. Let f be defined on an open interval continue the point C. We will select f is continuous at C if limit f(x) at 10 to c equals fc. How to understand the expression? Yes, require 3 things, means require 3 conditions. Condition 1, the limit f(x) must exist. Second condition, fc exists. This means c is in the domain of f(x), means f(x) is defined as c. Third, the 2 values, they are equal. Limit exists. f(x) is defined at c, and the 2 values are equal. Pay attention to, if any of these 3 conditions fails, and then f is discontinuous at c. So now, according to this, how to determine f(x) is continuous or not, according to the 3 conditions. So now look at the theorems of continuous of some functions. Theorem A, continuity of polynomials and rational functions. A polynomial function is continuous at every real number given C. Corresponding, the rational function is continuous at every real number C in its domain. Look at theorem B, continuity of absolute value and nth root functions. The absolute value function is continuous at every real number C. Similar meaning, the nth root function is continuous at every real number c if n is odd number. N is odd number, we don't care the positive or minus real number. So we have the case 3, the nth root function is continuous at every positive real number. Why positive? Because if n is even number, the given condition n is even number, we require at every positive real number c. At this time, the expression has some mathematical meaning. Now look at theorem C, continuity under function operations. What are our operations? If f and g are continuous at some real number c, and then the corresponding expressions are continuous too. The first, kf, means k times some real number. The second, f plus or minus g, and then the product of fg, f over g. Pay attention to f over g, gc doesn't equal 0. N power or nth root If nth root fc less than 0, n is even number. Odd number we don't care, but n is even number. Pay attention to fc less than 0. Now look at theorem D. Continuity of trigonometric functions sin x, cosine x, tangent x, cotangent, and secant, cosecant are continuous at every real number in their corresponding domains, always continuous. Now look at theorem E. Composite limit theorem. Limit gx equals L. If f is continuous at the point L, we will have this. Limit f g x tend to c, we can change the order of limit and f. Change the order, so equals f limit. F limit, the limit gx exists, means some number capital L, so equals ff. In the composite limit theorem, pay attention to limit f equals f limit. We can change the orders of f and the limit. So now look at this. If f is continuous in a, b, means open interval, how about the left hand point and the right point? If for the point A, f is right continuous at A, what is our right continuous? Means limit fx equals fa. Right continuous means f tend to A from the right side. How about the endpoint B? F is left continuous at B. What means left continuous? X tend to B from the left side. Means limit fx equals fb. We don't care the value about b plus. We only care the x tend to b minus. We care x tend to a plus. At this time, f is continuous on closed interval a and b. Pay attention to the three conditions. F is continuous in open interval. At a, right continuous. At b, the left continuous. The result, continuous on the closed interval. Now we look at the theorem F, intermediate value theorem. If f is defined on the closed interval a and b, given condition, f is continuous on the closed interval a and b. For any w belongs to fa and b, we will always find some c belongs to ab such that fc equals w. Try to find c. C means there exists some c such that fc equals w. So now look at our another definition. Definitions of continuity of some functions. The first, left continuity. What means left continuity? Limit x tend to x0 minus from the left side. Fx equals f0. This means fx is left continuous, means continuity from the left side. Look at the figure. Left continuous, x0 is our defined left continuous from the left side, corresponding this expression. In the similar way, we have another idea, right continuity. Limit I tend to x0 plus fx equals fx0. Fx is right continuous at the given point, means x tend to x0 from the right side. We have this figure, right continuous. Yes, in this point, continuous. Try to understand the two figures. Fx is continuous at the given point x0. If and only if fx is left continuous and right continuous at the same point. Continuous, equivalently left and right continuous. Now look at example 1. Prove that f(x) expression is continuous at the given point 0. How to prove? Proof question. It is continuous at the given point, including our definition. By the definition, this expression limit at tend to c f(x) equals fc. Do you remember this expression requires 3 conditions? So the first, we can check limit exists or not. I tend to 0. I tend to 0. Sin 1 over x is bounded. 0 times some bounded expression corresponding to the limit equals 0. Another fx means f0 equals 0 is defined at the given point, and the 2 values, they are equal, always equal 0, according to our definition. So fx is continuous at the given point 0. We have some summary. How to prove fx is continuous at a given point? Yes, you should check the limit and the definition exist or not. They are equals or not. Now look at example 2. Determine fx is continuous at 1 or not. Do you remember the property continuous? If and only if left continuous and right continuous at the given point 1. So now we will check. X tend to 1 minus. 1 minus means left continuous or not. The limit fx. X tend to 1 minus. X tend to x from the left side. Left side means this expression x squared. So equals limit x squared. X tend to 1 minus, together equals 1 squared. How about f1? f1 equals y squared. Together they are equal. According to our left continuous definition, this means fx is left continuous at the given point, left continuous. Fixed point, so now look at, if it is right continuous, x tend to 1 plus fx. Tend to 1 plus equals the expression I tend to 1 plus means less than 1. X plus y equals 1 plus y equals 2. 2 doesn't equal 1. This means not right continuous at the point. So for our fx, it is left continuous, but not right continuous. So we have fx is not continuous at the given point 1. So now look at our summary. The definition, f is continuous at some point if and only if means equivalently. This expression requires 3 conditions. Limit exists. F is defined at the given point, and the 2 values are equal. F is continuous at some given point if and only if means equivalently. Fx is left continuous and right continuous at the given point. Using the property, try to determine fx is continuous or not at some given point. So now look at question 1. Fx is given equals sin 1 over x. X doesn't equal 0. If x equals 0, fx equals 0. Determine fx is continuous or not at the given point 0. How to do this question? Determine. Maybe you can, according to our definition, we can check the definition f0. f0 equals 0. According to our given condition, fx is defined at the given point 0 equals 0. Now we will consider the limit. The limit x tends to 0 fx does not exist. Why does not exist? We will look at this expression. X tends to 0 fx equals tends to 0 means non-zero. x non-zero at this time equals sin 1 over x. Corresponding, the values will jump between -1 and 1. Now look at corresponding the figure. Y equals sin 1 over x, the pink curve. X tends to 0. Sometimes sin 1 over x equals -1. Sometimes sin 1 over x equals 1. Anyway, f(x) will jump between the two numbers -1 and 1. Do you remember the definition limit? If the limit exists, means the limit is some real number. And in this figure, the sin 1 over x will jump between -1 and 1, means the limit does not exist. So we will have f(x) is not continuous at a given point between the limit does not exist. Now look at question 2. f(x) equals this expression minus f(x), x less than or equal to 0. f(x) equals 1 plus x, x less than 0. Is it continuous or not at a given point 0? In the similar idea as in question 1. From this, we know f0 equals 0. How about, yes, this expression, x equals 0, f(x) equals -0. -0 means 0. So f0 is 0, f(x) is defined at the given point. So now look at the limit. I tend to 0 minus. 0 minus means less than 0. Taking in this price, minus x equals 0. How about I tend to 0 plus? I tend to 0 plus equals 1 plus x. Why? I tend to 0 from the right side means x less than 0. So we are taking about the 1 plus x. At this time means 1 plus 0 equals 1. Together, we can from this figure, okay? I tend to 0, from the left equals 0, from the right, the limit equals 1. Anyway, the left limit, the right limit exist, but the two values, 0 and 1, they are not equal. This means the limit f(x) does not exist, means the condition 2 fail. Limit does not exist. So we have f(x) is not continuous at a given point 0. Class is over. See you next time.